Hello, everybody. This is Oguzhan. I'm very happy to be here. Thank you very much for the organization here. So, I am a regional systems engineer manager, works for HP Aruba Networking, and I will be talking about warehouse Wi-Fi today. Sometimes, unfortunately, we are missing some basic stuff, and sometimes, you know that we all Wi-Fi geeks, we are doing, sometimes over-complicating things, sometimes over-engineering things. So actually, we realized that this is happening in the warehouse space as well. In warehouses, whenever we are talking about warehouses, we are all talking about external antennas, right? External antennas and some directional antennas, external antenna cables, RF cables, and lots of things on that. And actually, we realized that it may not be so much, obligation to all the time using the external antennas on the warehouse Wi-Fi design. So the problem definition here is, of course, also for some reasons, for some specific use cases, we may use external antennas for warehouse designs. That is for sure. However, the question is that always needed? Always needed? We always need to use, some costly, sophisticated in terms of sometimes installation or maintenance, I mean. So that kind of, the external antennas with lots of stuff, lots of, cables, etc. Is that always needed? So the question is that, and today, I will be talking about that, and I will be showing you that it may not be so much necessary, okay? So let's work on the question a bit as well. So why it may be a bad idea to use the external antennas in the warehouses, because actually, when it comes to the material cost, actually, it may be costly, and also especially after the MIMO applications, right? There should be much more, polarizations in the antenna. If it is 4x4, it may be even complicated. If it is 2x2, even less complicated. And also, they may be dual band, single band. With the introduction of 6 GHz, they may need to be, after the approval of the external antennas on the 6 GHz, of course, they may be, triple band. This is, in terms of material costs, that may be some kind of, extra sophistication on the material side, the hardware design side on the external antennas. And what about the design? What about the Wi-Fi design on that? The design could be tricky, right? What about adjacent or co-channel interference? What about the APs are scattering, the external antennas are scattering to each other? We are seeing lots of deployments, especially in the big buildings, in airports, terminals, that external antennas are used. However, unfortunately, the external antennas are shooting signal in one direction, and unfortunately, we are seeing that specific signal in lots of different areas as well. That is because of the scattering, right? That is as if you are trying to light up your living room with a highly directional, concert lights. You remember, you understand what I mean. The highly directional, such as lasers or something. You are trying to light up your living room in your home with highly directional lights, and light is bouncing towards ceiling and it's going everywhere. This is so much scattering, right? So we are seeing that kind of phenomenon in the large areas with lots of, bouncing areas around with big spaces like warehouses and also terminals, some big areas as well. So especially people are underestimating the gains of the external antennas. These are adding too much gain. These are adding too much, TX power when it comes to the EIRP, right? So, and also sometimes we are seeing the possibility of power mismatch, right? The client can hear the signal, but the AP cannot hear it. That is some possibility of power mismatch is also there. Oh, when it comes to installation, it is labor intensive. Believe me, it is a lot of labor. For each AP, sometimes it can go up to 8 RF cables and actually 16 connectors to be make them weatherproofed, okay? So weatherproofing is also important. I'm an amateur radio enthusiast, actually. I'm building antennas in my home, etc. So antenna stuff is very tricky. It's not so much basic thing to just plugging the AP and it works. So you need to be careful for the RF leakage. You need to be careful about the weatherproofing in terms of water sealing, things like that. So it is very, very important to make them waterproofed in the areas such as, warehouses. In warehouses, of course, there is no rain, but, there can be some temperature fluctuations, and that is why there can be some condensation. That is why it is very, very important when it comes to the installation, right? So, and also maintenance, right? In maintenance, it's also important to check if everything is working well after you installed it correctly, after maybe 1 year, 2 years, etc. So external antennas, for example, if you are having 50 APs, 60 APs in one warehouse, in maybe hundreds of APs in a warehouse, you have lots of cables, lots of weatherproofing you need to check periodically maybe. So instead of that, what about using omni-directional? So, in our Wi-Fi world, especially in the warehouse designing space that we are talking today, if we are saying warehouse Wi-Fi design and also omni world together, and I'm sure that many people are thinking like that, oh no way, no omnidirectional antennas in warehouse. No. I know why we are saying absolutely no to that. Because in omnidirectional antennas, we know that the main signal is going to east and west, right? To all directions, but not so much downwards, right? Omnidirectional. Signal is going this direction and also this direction, right? That is why the fear is that the AP is very high in the ceiling and APs will be transferring towards each other. They will decrease the power. There will be no strong signal in the floor. That is the main fear. However, I am not talking about regular omnidirectional APs, okay? I'm talking about down tilt. Internal down tilt omni access points, okay? Internal down tilt omni APs. So if this is the AP, if that is the AP, the signal is not so much traveling, east and west. Instead of that, it is going downwards to the floor. But how much? We will be talking about soon. So actually, with the internal down tilt omni APs, you are just putting the AP. That's it. Just putting the AP in the ceiling. Maybe it is 7 meters, maybe 6 meters, maybe more than that, maybe 10 meters, 20 meters. Actually, yes, believe me, it is pushing the signal towards the floor, okay? So it is working very nice if the AP is internal down tilt omni. I am not saying this vendor AP, this vendor AP. If you are, seeing an AP which is internal down tilt omni, which is very nice for warehouse deployments, and instead of spending lots of time for very complicated over-engineering design, just put your APs to the ceilings, okay? So let's see some real-world examples, okay? Real-world examples. Thank you very much for Shock Markets in Turkey, Istanbul, for allowing me to, their warehouse for this kind of small size survey work. So actually, in a real-world example, we are seeing an half full, half empty warehouse here. We intentionally selected this because actually we are seeing here that, some shelves are full, some shelves are not. Of course, in a minute you will be seeing that. Of course, it is affecting the coverage. It is affecting the coverage. And actually you are seeing the AP here. I'm not sure if my mouse cursor is visible or not. AP is here, and close-up lookup view is that. That is a regular, down tilt internal omni AP, down tilt, AP number 17. So actually, that AP is over there, and when we measure the distance from the floor to the AP itself, it is 7.8 meters, which is roughly 25 feet, around 8 meters, we can say. And actually, in that distance, it's not so much, very, high ceiling, actually. However, we will also see the coverage in a minute. If that AP in that space covering correctly, or are we seeing some weak spots, right? So let's look at the coverage here. So this is a very quick coverage and very quick some data points from that location. We have some aisles with 2 APs. We have some aisles with 1 AP only. So actually, in this 2 AP aisle scenario here, 2 AP aisle scenario, between the APs on the floor, we are seeing minus negative 59, 61, pretty much, very nice signal. And also under the AP, exactly under the AP, we are seeing minus 45, very powerful signal under the AP, when the distance between floor and AP is 8 meters. Actually, between device and the AP, it should be 7 meters or something like that. So it is putting very nice power. Please note that the AP EIRP is 15 decibels, dBMs, for all APs in this scenario. Deployment is 5 gigahertz only, and there's no 2.4 gigahertz coverage at all. No 2.4 gigahertz, just 5 gigahertz, okay? So, the interesting thing is that I intentionally did this. So, in the lower side of this lower side here, you are seeing that the AP 17 is not, penetrating too much to the neighboring aisles, right? Not too much penetrating. However, in AP 16 is penetrating much more than that. Why is that? That is because of the load on the shelves, okay? So I intentionally selected this aisle because in the area where we put the AP 16, at that time we were surveying, we saw that the shelves are not so much full. That is why it is penetrating to the neighboring aisles. The critical point is that, please, in that type of design, please do not think that maybe let's put an AP here, it can cover the next, it can cover the neighboring aisle. That is not good. That is not correct, okay? You should put 1 or 2 APs, given that based on the distance of the aisle, of course. You need to put 1 or 2 APs to each aisle. No, it is not, completely wrong not to put any APs to aisles, okay? There should be at least 1 AP in each aisle. So whenever the shelves are getting full, okay, so we are seeing the APs are only penetrating, covering the aisle, and they are not, covering the neighboring aisles, right? That is why we need APs on each aisle. So that is a 2 AP aisle scenario. Let's look at the 1 AP case here. So that is the worst case. Number 15, AP number 15 here, right? The worst case is that if the terminal, handheld device is here, when it is, for example, in my testing, it is 28 meters away from the AP, okay? 28 meters away from the AP. And of course, the signal strength in that situation is negative 68 or 70 dBms or something like that, and all handheld terminals, we are using Zebra MC33s mainly, and all working fine. So this is a real-world example, and this is my last 4 minutes, and what if we go much more than that as an only for experiment to see how far This AP is goes in an open space environment, towards the floor, or actually from its front plate, I should say. So AP is, somehow to show that, AP is like that, and the main signal is under the AP, right? So what is that distance? What is the distance between the front cover of the AP and the Wi-Fi client here? What this distance can be in the real world? 20 meters? 40 meters? 50 meters? How much it can go? That is a real-world experiment, just an experiment. In a balcony, okay? A great guy in my team, Metin Sönmez, if he watches this YouTube video right now, thank you for letting using his balcony for this work. Actually, we put an AP to the balcony. It's showing like that. And actually, we tested how far we can go based on the garden and stuff like that. Of course, we cannot go kilometers. So we went away, and we found a car to stabilize our laser measure, and actually it was 71 meters. 71 meters, that was 230 feet, and we measured signal strength. We measured latency. We measured bandwidth as well in that direction, bidirectional bandwidth. And also we measured fire rate, right? Of course, we couldn't target the AP because actually we didn't bring the second tripod for that, and my hand was shaking because in that distance, actually, you cannot put your laser pointer to the AP. Actually, it is showing here, and AP actually is here. But it's okay. It's okay. It's 70 meters or something like that. And actually, what about signal strength? Signal strength on my iPhone 15 Pro is 71 decibels. On iPhone was reporting that. 71 dBm, okay? It was consistent, and AP was facing directly towards us. And also it was complete line of sight, right? Line of sight, no obstacles. And what about latency on 71 meters? Latency was about 5 to 6 milliseconds without any packet loss. Of course, channel utilization was low. That was only for 5 gigahertz, okay? 5 gigahertz. And AP power in this experiment is 24 dBm. Channel width was 20 megahertz, okay? So what about bandwidth? What about bandwidth? With 71 meters, channel 120 megahertz channel with 24 EIRP, and throughput was around 90 and 95 megabits per second, okay? 71 meters from AP front plate, okay? So, what about the latest one? What about the AP reports about our SNR? How much AP can hear us, okay? And also, what's the fire rate between the AP and client, okay? AP reports the SNR of the client 20 dB, okay? 20 dB SNR of the client. File speed is around 120 megabits. We didn't check the MCS for that on the AP side. Based on the file speed, it was 121. It was either MCS 10 with one spatial stream. Why it is one spatial stream? Because outdoors, you cannot get 2 or more spatial streams. If you have little or no bouncing, multipath environment, you are getting back to one spatial stream, right? So it was MCS 10, 71 meters from the AP, from the omnidirectional down to the AP, okay? MCS 10, one spatial stream, 1024 QAM, and 34 FAC, and 1600 nanoseconds of guard interval. Or it was MCS 11, 1 SS and 1024 QAM, 56 FAC, and 3200 nanoseconds guard interval. It was either one of them, I'm not sure. So it was very nice performance. So it can go up to, in your warehouse designs, you can use that kind of AP from any vendor you like, from maybe in 10 meters, 15 meters, 20 meters ceilings. So signal is very strong, and as a result, it is possible to use down tilt APs in that type of scenarios. Thank you very much for listening. Thank you.